students. Here I am again, present with the chapter Units and Measurement. So far we have studied many things in Units and Measurement. I hope you must be understanding that chapter. In the last class I had explained you about the errors that do exist in the mathematical calculations like addition, subtraction, division and exponential mathematical calculation. I hope you must have understood that one. It's easy. You can go through your book and do the numericals. You will find it easy. Now today I am going to start with fundamental formulas or dimensional formulas that do represent any physical quantity. Now question comes, what is dimension in general? Dimensions are the powers up to which any physical quantity is expressed. Right? So how it works and in what way it goes, let us see. But before that I would like to make you remember that what are the 7 fundamental physical quantities and their units that we had already seen in our previous classes. You must be remembering all those: mass, length, time, luminous intensity, current, electricity and all that. Right? So those are 7 fundamental physical quantities and there are 7 dimensions up to powers of which any physical quantity is expressed. Right? So how it works, let us see. So here it is. Now we are going to start with the dimension of a physical quantity. Dimension of a physical quantity. Dimension, as I have already just now told you, the dimension of a physical quantity are the powers to which dimension of a physical quantity are the powers. Dimension of a physical quantity are the powers to which the fundamental quantities must be raised to represent that quantity. So dimension of a physical quantity are the powers to which the fundamental quantities must be raised to represent that quantity. Now let us say this statement by an example. Let us take an example for force. Now we all know that the formula for force is nothing but mass into acceleration. Right? Now let us move further. Here mass is the fundamental physical quantity. So I can write this mass as capital M. Now for acceleration part. Acceleration, as we have learned in the lower classes, that is nothing but velocity by time taken. Now further proceeding with that, m into velocity. Now velocity has again a formula, that is displacement by time, right? So for velocity we can write displacement by time, but this displacement is nothing but length, right? This displacement is nothing but length. So ultimately we are putting length by time upon time. Length by time for velocity and time for denominator we are putting t here. Now arrange this. It will become mass into length upon t square. So just go through the formula. It will nothing but mass into length upon t square. So arranging it, m to the power 0, m to the power 1, and for length to the power 1, but for time it becomes minus 2. When we take it in numerator, it will become minus 2. Clear with m, l and t minus 2. So these are the powers about which we are talking. So the dimensions, this mass, length and time are the dimensions, the powers of which is being represented as what? The quantity. And what is that quantity? Force. So this is what the statement comes up with. Very easy to go at this point. And we have to start with the initial formula, that is force equals to mass into acceleration, then mass into the usual general formula, putting all this. Remember this for all the distances, either it may be distance or displacement, always put length for that, and t will be remains for time. So putting like this, you get the dimension of a given physical quantity. Let us take another example for density. So let us take another example, that is what for density. For density we know the formula. If you can tell me the formula for density. Yes, it is nothing but mass upon volume. Mass upon volume. Now again proceeding with the same idea. Mass, for mass we are keeping m. Mass is already a fundamental physical quantity, so for that the abbreviation used is capital M. Now for volume, we all know for volume what formula we can use. If you can tell me, yes, what I should use the formula for volume? Yes, it is length into breadth into height. Length into breadth into height. But again, see, the important point to be noted here is that length is itself a length, breadth is also a length, and height is also happen to be length. So this formula comes out as mass upon length into length into length. right? Now here 3 times length comes. So how we are going to represent? It will be like that: m to the power 1, l to the power minus 3, because all these 3l will go in numerator, so it will be inverse function, so minus 3 comes. And what about t? For t we are putting it as t to the power 0. So density has this much power, up to which the dimension of this physical quantity is expressed. I hope you must have understood. It's not very hard, it is easy, right? So there are many formulas. All the formulas can be expressed in this way, the way in which we are moving. I have just given you an example that how the dimension used to represent any physical quantity. So let us take one more example to you. For momentum. Let us take an example for momentum. I hope all of you can do it. For momentum, what is the formula? For momentum, which formula we are following? Please tell me. Yes. What is the formula for momentum? Yes, please tell me. Yes, it is nothing but mass into velocity. Nothing but mass into velocity. So, how to proceed with now? For mass, capital M is there, and for velocity, what I should write, or in place of velocity, it is nothing but L T minus 1. When you calculate, you will come out with this one. So ultimately it will be expressed as m to the power 1, L to the power 1, and 2 to the power minus 1. So within these 3 examples, you might have come to know that how we should use dimensions to represent any physical quantity, right? So let us see dimensional equation. Dimensional equation. Dimensional equation is nothing but it is a equivalency of any physical quantity with that of the power of the dimension. That is what we have just seen. For example, for force, what we have seen, m l t minus 2. So this is what dimensional equation for force. Just now we have seen for force. Let me remind you, this is what this force equals to m to the power 1, L to the power 1, right? And then t to the power minus 2. Same is coming out as here. This is what? Nothing. It is equivalence. That is LHS equals to RHS. That is force equals to m minus 2. Right? Now, the similar way you can take another example, that may be pressure. Now for pressure, what is the formula? What is the formula for pressure? That is force per unit area. Force per unit area right? It is nothing but force upon area is here. Force per unit area. Area means length into length. So we can write L square. Now if we put the formula for force, that is what? ml T minus 2 upon L square. L square for here, and for force ml T minus 2. So what we will cancel here, one L will be cancelled, and what we come out with? We come out with as the answer as m L minus 1 T to the power minus 2, right? This is what for pressure. So this is what the dimensional equation, right? And how a physical quantity is represented in terms of dimensional formula or with the dimension, we will just see. So dimensional formula as such, as here being shown, actually represent the physical the fundamental physical quantities on which that physical quantity represents or depends. So force depends on mass, length and time. Similarly, pressure depends on mass, length and time. So almost all the physical quantities depends on dimensions. There are certain quantities that do not depend on dimension, and what are the properties of dimension, that I am going to tell you later on in next video. Now homework for today. For homework part, you have to find the formula. Find the formula. Which formula? Dimensional formula of volume, number 1, number 2, power, and number 3, that is area. Find the formula, dimensional formula for volume, power and area. One more, that is work. Easily you can find by using this methodology. For volume already I have done. For power, you know the formula, work done upon time taken. Area already we have done here. And for work, you know the force into displacement. Already you know the formula for force, and displacement is being represented by length. So easily you can do. So thank you for today. Thanks.